All right. Hi, guys. Welcome to your last math video of the year of your FST career. Um, Take a little bow, right? It's pretty impressive. So, yeah, let's get into it. Make sure you finish out this week strong. Right. We just got a short week. We got the beginning here is our last bit of material. Then we just have like an exit survey with a little video in there, not math related. And then you got some time to catch up if you need to. So make sure you're finishing out the year strong in this class and in your others so that you can go into summer hopefully enjoying it. So let's get rolling. This section in FST is called Intro to Confidence Intervals. And again, for kind of like similar to last section, if you're taking AP stats, this will be extremely helpful. Depending on what direction you're going, you may see this more, you may not see this very much. But basically, confidence intervals help us give a range of values that are similar to or help us determine like a true value or our true mean. So an idea is like if you take a sample, you calculate the mean, let's say like mean grade point average, and you take a sample of some of the high school kids, you get an idea. And then if you calculate your confidence interval, you can kind of say, all right, our mean GPA is maybe between 2.5 and 3.2, right? So it gives you an idea of if you surveyed the entire population, where that mean would fall. And one thing to think about is, we'll get into a second, is how confident we are with each interval. And that's kind of what we're talking about today. That's why it's called the confidence interval, right? We'll talk about being a certain percent confidence that our mean will fall in between these two values. All right, so looking here, we're going to look at this example. It kind of breaks it down, then we'll look at another example. So first of all, we measure the heights of 40 randomly chosen men. We get a mean height of 175 centimeters, and we calculate our standard deviation to be 20. Right, so we've got our sample size of 40, we've got our mean height of 175, and we've got a standard deviation of 20. All three key things. We want to come up with an interval that we can say, all right, with 95% confidence, we know that our actual mean of all men fall between these two values, right? And so we go through and calculate it, and we get this value of 6.2. Right, and so that says that if we add 6.2 to 175, our mean, and we subtract it, that's what that plus or minus is, that we get this interval of 168.8 to 181.2. Right, so we know with 95% confidence, which is what this says, that our actual mean height of all men, right, even though we only took a sample of 40, of all men will fall within that interval. Right, so it just tells us that our mean falls within that interval. That's what our confidence interval tells us. And so again, this tells us that with 95% of the time, if we try to find our average height, it'll fall within that range. But it also does mean, right, if you're 95% confident, that means you're 5% not confident. Right, so that means that 5% of the time, your mean will fall outside of it. So let's say one of the times you're in Holland, right, which is the Netherlands, which is the tallest by person in the world, right? So your mean would probably not fall within that range. So 95% of the time, we're sure, and that's what this confidence interval helps us find. Now we're going to talk about actually finding our confidence interval. All right, so three key things that you need. Your first step, three key things. You need to figure out your number of observations, right? Or like number of people surveyed in that last example. Okay, and we denote that with the letter N, right? N number of people surveyed. Our mean, right? You got to know your mean after you calculate it. And we say our mean gets represented with an X with the bar over top of it, X bar. And lastly, we need to know our standard deviation, which makes sense. This time we use an S. All right, so those are your three key things that you need, and we'll talk about the last thing that you need. Next, we want to decide how confident we want to be, right? And so something to think about when we're choosing how confident we want to be is that the more confident you are, the wider the range is going to be, right? So it's easy to say, oh, yeah, I'm 100% confident that these GPAs will be between zero point 0.0 and 5.0, right? You're definitely going to be there. Now you're going to be a little less confident saying that, okay, maybe I'm 50% confident that it will fall between 3.0 and 3.1, right? So smaller the range, the less confident you can be, larger the range, the more confident you can be. For the most part, a lot, you will either use 80, depending on what it is, but most commonly you'll either use 95 or 99. And if it doesn't give you a confidence interval to like collect or use, you should either use 95 or 99, right? Those are two most common, right? Because 95, there's a 5% chance you're off. 99, that means you're pretty darn confident, right? There's only 1% chance that you're off. And so in order for us to calculate this, we need the z-score, which we talked about last week. So we need the z-score for each one of these confidence. So this table is very important, right? This is our z-score. This is also on your notes, I believe, so you should be there to have it. And it's also on, well, there's no quiz this week, so it's on your notes for when you're practicing. And our formula that helps us find our interval is we have our mean. Then we have to do two calculations, right? We have to add it, we have to add this value, and we have to subtract that value from our mean. That's how we get our upper bound and our lower bound. And this z is a z-score, so we have z, our z-score, times our standard deviation divided by the square root of our number of observations. And so it's very important that you do this chunk together, and then you add and subtract it from your mean. All right, so let's look at it. Last example for the year, people. I hope you're as excited as I am for summer and this to be our last example in FST. All right, so we want to know, are your apples big enough? You own there are hundreds of apples on trees in your orchard, right? Congratulations, your family owns an apple orchard. Even though I feel like people most commonly go there for the donuts and cider, you own an apple orchard with a bunch of apples, and you want to know if yours are going to be big enough, right? So you randomly choose 46 apples, right? And find that your mean is 86 grams with a standard deviation of 6.2 grams. And we want to determine a confidence interval to determine where our true mean size of apples for your orchard lies. Okay, so first of all, let's break this down. So first of all, determine a confidence interval. It doesn't tell us what confidence interval to use, so we can choose. In this case, let's say we're going to use a 95%. Then we got to go back through and make sure we find our three key things. So first of all, let's find our mean, right? We found our mean is 86. X bar equals 86. We also need our S standard deviation, which in this case is 6.2. And we need our N, our number of trials or observations. And in this case, we choose 46. So N gets us 46. Lastly, we said 95. Let's get our z-score that goes with that. Let's go back up to this table, right? Definitely don't have these memorized. And in this case, we're using 95. So we're going to pull 1.96. 1.96 is our z. 1.96, and that is our z. Okay, so let's set this up. Let's change our color so we know we're doing something a little different. Okay, so in order to set this up, we take 86 plus and minus our z 1.96 times 6.2 divided by the square root of 46. If you're typing this in your calculator, I would do this chunk first and get out a value. All right, so if we type that in, we get out approximately 1.792. So we get 86 plus and minus 1.792. And then I would break it into two pieces, right? Do the addition, then do the subtraction. So 86 plus 1.792 and 86 minus 1.792. And if we go to our calculators to help us get our nice final answer, we get, I don't know why it even lets me change the color of my, let's go Spartan green, end the year with some Spartan green. We get 87.79 and we get 84.12. I wrote those backwards, so let's rewrite them. So we know that with 95% confidence, right, with 95% confidence, our mean should fall between 84.2, what are we talking about, grams, and 87.79 grams, right? And this is with 95% confidence. And so that just tells you that for whenever you choose to find your mean of your apples or your mean or whatever, that that mean should fall within that interval. And we can say that with 95% confidence that our mean should fall within that interval. All right, congratulations, people. That is the last notes. Make sure you finish up the rest of these notes. Take the survey, do your last quizzes for the week. You should be done by Wednesday, right? The Wednesday is our last survey. And just make sure you finish up for the week, catch up on anything that you missed so you make sure you get complete credit. You guys did awesome, and enjoy your summer.